The demonstration you're about to see shows the tremendous power of air pressure. Now, it's often said that we live at the bottom of an ocean of air, with huge forces pressing on everything all around us. And in fact, on every square meter of surface, 10,000 kilograms of air are pressing down. Or, if you want it in English units, on a square yard, we have 20,000 pounds approximately. So why aren't things crushed? Well, luckily, everything's pressing out with the same force. Today we're going to be using a 55-gallon steel drum to explore air pressure. And I have a felt board here to show some of what's going on inside and outside the drum. Now here's the drum, and there's an opening in the top. And these yellow circles represent air molecules, nitrogen, oxygen, a little bit of carbon dioxide, what you'd find in the air. These on the outside are certainly exerting great force on the drum, but they're balanced by the air pressure on the inside pressing out. What we're going to do is set up a situation where there's nothing inside the drum, and then see what the air can do. Now, the first step in this demonstration is for us to put some water inside the drum, and the water molecules are going to be represented by these blue circles. Since they're liquid, they're going to sit here at the bottom quite close together, and they can easily push some of the air out of the way. And we get a situation like this with water in the bottom of the barrel and air in the top part. Now the barrel's not going anywhere. It's quite strong. It can hold the pressure of the water out. There's air pressure pressing in, air pressure pressing out. It stays just as it's always been. What's next is to put some fire underneath this barrel, or actually put the barrel on a fire, and heat the water up. Now what happens? The water molecules begin to move more and more quickly. The most energetic ones jump out into vapor form.
Okay, now we just
and
have to,
they will push some of the air out as the water begins to evaporate and eventually begins to boil. Finally, we'll get a situation like this, where the barrel is filled in its upper part with water vapor, water in a gas form. If we keep boiling the water, we can actually force some of the water vapor out in the form of steam. But still, the idea here is that we have the tank filled with water vapor. Now here's what we want to do. We want to make it so that there's nothing inside here. How do we do that? Well, we begin by tapping the can with its top and taking it off the fire. Next, we spray it down with water, some cold water on the outside, causing this water vapor to cool off and condense back into liquid water, and now we have nothing pressing out in this area. But meanwhile, we have this incredible pressure on the side.
So it takes a while, apparently.
Still, the pressure of air pressure. And the sides collapse under that tremendous pressure.
Fingers are gonna get cold.
That was exciting.
That's air pressure! We live at the bottom of an ocean of air, crushing a 55-gallon drum! Yes!
Oh, what a great
But we're sad. We want our can back. We don't want a crushed can. Can we do anything about it? It turns out we
Put it
can.
on up there, Randy.
Simply put the can back on the fire,
It's still got water in it.
like so. Heat this water up so that it begins to evaporate, creating pressure on the inside, forcing the sides back out. As you will see in the speeded up version of our demonstration. The same effect can be demonstrated in your kitchen at home. What you need is a can, a little bit of water, and just put the water in the can just like we did with the 55-gallon drum, just a little bit in the bottom. And we begin to heat it up. Now, of course, at this point, the can's not crushed. There's air pressure on the outside, but there's air pressure on the inside. And the can just sits there. Now, as we heat the water, the most energetic molecules are going to jump out into vapor form. They're going to push some of the air molecules out, and eventually we can fill this whole can up with water vapor. Can still won't be crushed because water vapor pressing out, air pressure pressing in, they're equivalent. As we add more water vapor, some of it will come out the top, and it'll still be equal pressures. The can won't do anything. When we finally get to the point where we feel like this thing is totally filled with water vapor, when the can is maybe, the water in the bottom of the can is at a rolling boil, I'll grab it and I'll turn it upside down into this bowl of ice water. Now with the 55-gallon drum, we capped it off and then we cooled it down. In this case, I'm going to turn it upside down so that the water sort of plugs the hole here at the top, and air pressure will crush the can as the water inside condenses. Remember that when the water inside condenses, there won't be anything pressing out. There will be the air pressure pressing down in on the can, and that should be plenty to crush this can. We're just about there at a boil. Let it boil for just a minute or so that I'm sure that that thing is filled with water vapor. And then I'll grab it with these tongs to move it to the ice water. It's boiling away. I grab it, turn it over, and that's air pressure. 14.7 pounds per square inch. Plenty to crush that can.